Good afternoon. It's very humbling to be following two multi-million-dollar, multi-year, multi-collaborator, multidisciplinary, multi-country projects. Really impressive efforts. I'm the counterpoint, I guess, as Siwa said, to provide a little bit of a contrast. This is work primarily done in collaboration with Juris Baldos. There are a few other collaborators as well. You'll become evident with the references. Brief overview of the talk. I do want to emphasize a point that David brought up about the importance of first looking at history to understand the future. We'll look at various drivers of the global food system and some critical adaptations. So I've been working over the last decade increasingly with climate scientists, and when you work with them, they insist on looking at history before you do anything else, and they insist on model validation. And they basically feel if you can't reproduce the past, it's difficult to do projections of the future, but if you can't reproduce the past, you have no hope, is basically their position. So it's a pretty hard line for an economist to face, and we've done our best to respond to that. Here's an illustration of that. So we want to go forward to mid-century. Let's first go back a similar length of period of time. So this is looking 1961 to 2006, FAO data on what happened to crop production, tripling of crop production. What happened to crop land use, net land use, it increased by just 15%. That's a remarkable difference, and that's, of course, the difference is being accounted for by the yields you see down there. Even more remarkable is the fact that in the face of this strongly increasing demand, crop prices fell over this period by more than 25%. So that's remarkable accomplishment. The model does a pretty good job at global scale replicating this, and we have papers exploring this at the regional level, which is obviously more difficult. The model also permits us to break out the different drivers of change, and this is really important when you're looking forward. You need to know what are the fundamental drivers. So they're the demand drivers, and in the past they were primarily population and income, and the supply side, namely technology, the improved yields, all the things that contribute to improve farm productivity. And you can see that the main driver in the past of output growth in the upper left-hand corner was population, and that was driving cropland use. Yields were driven largely by technology, also driven by demand factors because they are endogenous in the manner that David just mentioned. So crop prices were driven down because of these great improvements in technology advanced by the CGIAR, among others. So if we look to the future, the first thing you might do is just take the same model, the same historical drivers, and push them forward in time. And it's a symmetric situation with this model. Use same drivers going forward at the same relative rates, you get the same answer, namely continued price declines. That's what I'm showing here in the price declines. But that's not very interesting because we know things are changing in the future. That's not a very interesting way to project the future. Let's bring in some information about the future. First, population. And the striking thing about population, David mentioned demographics. It's the main driver in the past. Where's it going in the future? It's going down. The population growth rate is slowing. This is not even the growth rate. These are the annual, the decadal additions to global population. And you can see they were going up. Now we've been in a flat part, and they're poised to go down pretty dramatically to mid-century. So in the foot race between supply and demand, you don't have to run as fast to keep up with this slower growing population. Most of the population growth is, a large share of it's in Africa and largely in the poorest countries in the world. Those countries adding another person in Mozambique does not add as much burden to the global food system as adding a person in Washington, D.C. They consume less, a less richer diet, and so on. So for both of these regions, there's a dramatic fall off in that red driver of crop prices in this case, and other things. So if technology grew at the same rate, income per capita grew at the same rate historically, we'd see a dramatic price decline. That's not the end of the story, of course. Income's growing, and growing, fortunately, over the last decade in many countries in sub-Saharan Africa. In other developing countries, the growth rate has been pretty encouraging, and particularly relative to some of those earlier periods. That generates more food demand, a richer diet, for all the reasons mentioned earlier, more demand on the global food system. When we put that in there, we get an orange bar now, the income driver, that's actually larger than the population driver. So this is an unexpected result, see, one that hasn't been mentioned extensively, and that for the first time in history, I would argue, income dominates population as a driver. It's always been adding more people, you need more land, you need more production. Income being the predominant driver, that's a very important point. So what about technology? Well, it's difficult to project. This is really in some sense, the summary of our ignorance about the future. It's a hard thing to measure in the past, but Carlos Ludenia and myself and others projected this forward in the past, and we get, using that part of the green bar in the biofuels projections, we get a modest price decline going out to 2050 from 2006. If productivity growths were at the high end, a much stronger price decline, at the low end, price increase. So there's a lot of uncertainty there, and I would argue that when we're looking to the future, we should think not in terms of individual, are prices going to go up or down, but rather think about the probability of prices falling, because we don't know the future. We don't know what's going to happen to population or income. We don't know exactly how consumers respond to increased income. So it's not just the drivers, it's the economic responses that are uncertain. So here, this is a Monte Carlo analysis. We draw from these underlying distributions of possibilities, simulate the model many times, and find that using the best estimates out there from the literature, 2/3 of the results show a price decline over this period, but we can't rule out significant price increases, and this comes about when fertility is higher than expected. At the high end of the demographic projections, incomes at the high end, income elasticity of demand are high, and if productivity is low. So there's a whole range of possibilities, and the question is, where do your projections fall within this distribution? And we have cited in here a review paper where we review many of the models used to make projections and where do they fall in these distributions. But price declines globally don't translate into price declines in every region around the world, and the reason is that world markets are segmented. We don't live in the trade economist nirvana, where you can trade freely, that consumers in Ghana can access maize at the price that it's offered at in Iowa. Okay, there are big barriers to trade still. There's something called market segmentation. So as a result, in the sub-Saharan Africa region, in these projections, prices rise. They rise more than the world average. They rise significantly under the market segmentation scenario. And that's because you've got very strong demand growth there. That's where the population is growing. That's where the income is growing. And that's where productivity growth has been slow. We saw that in David's presentation of the yields, that low level of yield growth. With that projected into the future, prices in the region go higher, and that has adverse effects for poor consumers. If the trade economists achieve their nirvana, and that's the integrated market scenario here, Africa doesn't improve its productivity growth, their output growth will be much slower, and that's because they just can't compete in that kind of a world with low productivity. And that means massive imports, provided they can afford it, and that's the question David was raising. Can they afford it? What kind of adjustments would be required? But this is a dramatic scenario. So stemming that price rise without improvements in productivity means a lot slower output growth. What about climate change? I haven't mentioned this, obviously very important for Africa, South Asia, many of the poorest countries and regions in the world. And here the IPCC in their recent AR5 report notes that for some crops, there's already a drag on these this productivity growth. These are percent change per decade in productivity growth. It's getting harder and harder to achieve productivity growth in the face of higher temperatures and more frequent droughts. Here's the most recent analysis. It's work done by a former student of David Lobel, a meta-analysis of more than 1,000 IPCC studies, and synthesizing that into some estimates put on a global grid here. And this is for wheat at 1, 2, and 3 degrees warming. So the Agramonde study 1 degree is what they're hoping for. 2 degrees is what they fear they'll get by 2050. So you can see very different effects. 3 degrees later in the century, really devastating for wheat yields. But you do notice there's a mixture of colors here. And the mixture of colors means trade is going to be beneficial in that environment. You're likely to shift production towards the regions experiencing more favorable effects. For wheat, the CO2 concentrations in the atmosphere benefit wheat yields. So here's a study where we explored this question of trade as adaptation. We bounded the analysis with the red on the top, kind of an extreme case drawn from the AgMIP archives of climate crop model impacts, and the green being the favorable end. So think of this as extremes. On the left, we have the historically segmented markets. That's the world we live in. In that world, the most extreme climate scenario in South Asia, if the real pessimists are right, there could be significant impacts on the malnutrition headcount in 2050 solely from climate change. On the other hand, in the integrated market scenario, the good outcome is still good, but we really cut down the malnutrition, undernutrition impacts in South Asia in particular. So trade is valuable. Trade will be more valuable in the future under climate change, especially under the most severe scenarios. Another important avenue for adaptation is R&D. IFPRI, CGIAR are at the heart of that. And drought and heat resilience will become important in the future. These are estimates. URIS has led this effort to actually estimate the lag structure on R&D and how long it takes. If you spend money today, how long it takes that to be evidenced in productivity gains in agriculture. And it's a long time. It peaks after 20 years. It still has effects at 50 years. So we've asked the question in this context, given that we don't know the future, we've heard that there are many different SSPs, shared socioeconomic pathways and other things, different income and population paths, and we've asked the question, what would be the optimal path for R&D spending in light of this uncertainty, in light of the temperature and climate impacts uncertainty? And you see the dashed line showing there are many different paths. The optimal one in this context, we think, in terms of robust decision making, is the one that minimizes our maximum regret. So it's kind of a robust decision rule. You look at how sorry you'll be in terms of global food outcomes if you bet on one scenario and another scenario emerges. Minimize maximum regret suggests invest a lot more in the next 2 decades and let it fall off. The lower panel shows you as a percent of GDP. So more than double R&D spending as a share of GDP in the next 2 decades, then let it fall off as some of these pressures become less. So just conclude now. A lot of uncertainty about the food system in 2050. We've heard about that from the other speakers. I'm underscoring the importance of technological progress for food security, but as everyone in this building and in the CG system knows, it takes a long time for that R&D to actually be evidenced in improved outcomes for farmers. So it's important to be thinking about the future today. It's important to have this policy seminar today precisely because of this future uncertainty and the long planning horizon for some of these irreversible kinds of decisions. If we don't make decisions today, we can't come back 20 years from now and say, change that, we're going to redo that, reboot. And just underscoring again, the value of trade, free and open trade is going to be higher in the future, higher under climate change. I'm sure that's something my discussant Will Martin will like, given his interest in the topic of trade.